demonstration. So the first thing we need to do is scrape away any of the old corrosion and any of the old coating on top of the trace so that we expose nice, clean, shiny copper. Now I'm using here these Swan Morton surgical steel blades. The main reason I use them is because they have a curved blade and I find them really good for scraping. But as I say, I mean, it's not an essential thing, but it's just, that's what I like to use. So let's start off now, make sure we're in focus. Might just zoom out a smidge. Okay, so I'm just going to get my blade here and I'm just going to scrape away. And as you can see that as I scrape, that gets brighter, and that's as I take that corroded layer off the top and I'm revealing nice fresh copper underneath. It's not oxidized, so it's nice and clean. And what we want to do is we want to expose enough of this copper so that we can get a decent amount of solder, because the larger surface area that we have, the more secure this repair will be. If we just expose a tiny little bit of copper and just put a little teeny weeny wire across there, it's only going to be held on by a tiny bit here. But if we expose this whole area, it means that that wire's got a lot more to stick to. Okay, so that's basically prepared reasonably well. The next thing we want to do is use our flux. Now, as I say, this is a no clean flux gel. I use an Amtech one. Once again, links down in the description, but you don't necessarily have to go with the Amtech one. But as I say, what you're looking for is a no clean gel flux. There are plenty out there. This is the sort of thing you're looking for. And we basically just want to get that fairly liberally on top of that copper. Now we get our soldering iron and we get a little bit of solder. And what I'm looking to do is I'm looking to just tin that copper. So what I'm wanting to do is just coat the copper with solder. So let's get this on here now. Let's do that. So now we've got plenty of solder on that copper, not too much, but we've got enough to work with there. So the next thing we need to do is grab our wire. Now for this one, I am going to use my mid-size wire. I would be fine with the small stuff, but the mid-size wire is a little bit stronger, so I'm going to use that one. I'm just going to cut myself a length. I've grabbed just a length of, I don't know, 2 or 3 inches, something like that. Place it here, hold it in place with the tweezers. I'm going to put it right there. And then I'm going to get some, I might put some more flux on this. It never hurts to have a little bit more there. Then I'm going to grab a little bit of solder on the tip of my soldering iron, just like this. There we go. And then I'm going to hold this in place with my tweezers and melt that on there. Now, that's fairly lumpy there, but it has held quite well. That is definitely on there, no problem there. So now we just need to solder the other side. So once again, grab a little bit of solder onto the tip of my soldering iron. And there we go. And that's soldered on there as well. Now, it's a little bit lumpy. If I wanted to clean that up, I could just get a little bit more flux onto it here. I know I'm going heavy on the flux, but flux is a very important part of getting nice, smooth solder joins. So you can see that with that flux there, applying a little bit of heat, all of a sudden that's now looking super smooth. So let's just get a little bit more focus on that. So that's the wire there. I'm just going to nudge that with my my tweezers. Actually, I'm just going to cut the end off it now. Yep. Like that. And there is our trace repair. I want to check and make sure that it's all nice and secure. So I'm going to zoom into it a little bit here. Try and get it in focus. There we go. And then I will just give this a nudge with tweezers. And that's not moving. Okay, so now we'll just clean it up. Get my little Q-tip with a little bit of isopropyl alcohol in it. I'm just going to wipe some of this goop off. we really want to go to town, we can always just get a toothbrush with a bit of isopropyl on it, give it a scrub. And there, if you have a look, is a nice clean trace repair. That end is stuck on well, that end is stuck on well, and we've restored continuity. So that is it. Let's just do another one. We've got one directly above it, as you can see right there. Great big channel missing out there. So once again, we do our scraping. I might just flip this around. Okay, so let's scrape here, expose that clean copper. Nice. Scrape here, get any of that mask off and any corrosion. So we've got nice bright copper there. Once again, we get our flux on there. Whoops. And then we get solder first. It's very important to get the solder on this first before you start putting the wire down. It just makes the process a lot easier. If you've already got solder in one location, it's a lot easier than trying to get solder on both at the same time. So, there we go. Nice coating of solder on that copper. Once again, we get our wire and put that in place. Okay, then get a little bit of solder on the tip of my soldering iron. Grab my tweezers. Hold the wire in place. Oops. All we have to do is get one side done first. There we go. Melt the solder onto it. That's nice and secure. Now we can focus on the other side. Get a little bit more solder on the soldering iron. Yep. Hold that in place. There we go. Okay. Then again, just trim off the excess. Like that. And if I want to get that really neat, I mean, look, to be honest, that one is fine as far as I'm concerned, but I can always just put a little bit extra flux on there and just give it a quick brush. Created a bridge there. Don't want to do that. There we go. And once again, we have a nice, secure wire held on there, and we've repaired that trace. I'll grab my little toothbrush here and I'll give it a bit of a clean, get all that flux off it. And there you have it, another tidy trace repair. Now sometimes when you have a broken trace right near a via, such as we do here, a via is that little hole there, you may want to actually run the wire right through that hole to give it a little bit of extra strength. So that's what I'm going to do in this instance. I'm going to scrape this off, and yes, I am well aware of the fact that there are broken traces just absolutely everywhere here, but I am only demonstrating this one here. So let's actually run it from this via through to the other via. So we're actually going to be essentially recreating this whole wire with a new wire. Let's do the process the same as before. We do our scraping to start off with, and then I get a bit of flux on here. I get my solder and get that melted onto the copper like that. Okay, now I need this hole open, so I'm going to grab some solder wick, which I referred to at the beginning, and this is going to just take away any of that excess solder from that hole, so leave it exposed. So there we go. There's our trace all ready for repair. Sorry about the focus, folks. And then I'm going to grab my wire. I'm going to poke one end through this hole. I want to try and get enough of it poking through. There we go. That's through on that side. And I'm just going to bend that down like that. And let's solder that in. So get our solder here. There we go. Just grab my tweezers so I can hold this wire in position. There we go, that's in pretty good. Now we don't really need to run we don't really need to actually attach it to any of the copper along here because we're essentially completely replacing it. I'm just going to cut off some of the excess of this wire so I can feed the other side through the hole. There we go. Let's poke that through. It'll probably be easier for me to pull this from the other side, so I'm going to whip them around. There we go. So let's pull that through. And there's our other one. Let's flip him back over to the other side. Here we can see that's our wire. I'm just going to bend that to kind of match the contour of the original trace. I do that purely for neatness, no other reason at all. And once again, we get some solder and we heat that up. There we go. All right. I might put a little bit more on this side as well. Okay, so now rather than actually soldering it onto all of these little bits of copper in the middle, we're just doing it from end to end. And then I'm going to flip him over to the other side, and I want to actually carry that repair on to the copper underneath. So I'm going to scrape a little way here. Once again, get some solder onto that copper. Then grab my tweezers. This is a lot easier to manage now because it's secured well on the other side. Might grab 2 tweezers here so that I can once again bend this to the contour of the original trace, just so it looks pretty. I could definitely be using a much thinner wire than this. Okay. Then hold him down. There we go. Let's cut off the excess. And that's one end all done. And where's the other end? The other end is over here. Once again, let's scrape that. Get some solder. Get some solder onto the copper. And bend the wire. Cut off our excess once again. And there we are. So let's zoom out a little bit here. Can we see both of them? We've got that's going along there, through the hole, along the trace on the other side, out here, and then attached to there. So we'll give that a quick little clean up. A toothbrush. And let's have a look on the other side. I just want this to be a nice blob on this side. Even though I know it's soldered from the other side, I just prefer the look of it if that's got a nice blob on it, like that. There's a blob. And then we'll just clean that up as well as best we can.
And I like to use a little bit of flux when cleaning up. Do I have to use flux when cleaning up? No. Flux will help solder flow, and wicking will be much easier with flux than without. So now the area is clean, and let's make sure of that. We got our nice precise blade here, and very nice, very nice. I love that blade, I just love it. We have a second one also that will be posted on the side, and we're going to use this later on. I'm going to try it for the first time to cut the jumper wire after we solder it. Look at how precise this blade is, and it's a round one, so after we solder our jumper wire, we're going to cut it using this blade. Very nice, very nice. I just love when I get a new tool and it works and it makes the job easier. I love that. The thing is, when you are using the wrong tools, you get frustrated and the repair job will take longer to finish. And every time I have a tool that will help in the repair process and makes the job faster, I get excited. Okay, so we're gonna add a bit of flux, and then we're gonna prep those lines. When I say prep, I mean add solder onto those lines. And just like that. So we have solder here. I get a lot of questions where people ask, how does solder stick onto the tip of your soldering iron? That's a very good question, and I think to answer that question we need a whole video. I'll probably make one very soon. We have to make sure the tip is not oxidized, the tip is well maintained, and of course the quality of the tip. You have the tip thinners, but you do not want to use that unless the tip is at the end of its life. You want to extend its life, maybe 1 week or 2 more weeks, then you use the tip thinner. The tip thinner will brush a layer off the tip, and it's a temporary fix. The wire is soldered all the way through the trace, and let's test our blade. Let's test our awesome precision blade. Look at that. Wow. Wow. It didn't take much effort at all. That's one sharp blade. It did not take any effort at all. We're gonna cut the wire from here also. Let's do that one more time. Maybe we're gonna do it right over here. That is amazing. And I just love the handle of the blade. I just love the way it feels in your hand. Okay, I just want to make sure that this wire is not going to touch the pad right next to it. Great. Okay, just like that.
This Xbox is finished.
Okay.
I looked in the emails, you told me 139.
Yeah.
How much is the shipping?
Okay, so now that we have the wire soldered on, let's get excited again and cut that wire with the blade. Okay, let's cut the wire from right over here. I mean, look at how precise this blade is. This is amazing. We are dealing with a microscopic area, and look at how precise this blade is. And the tool is very cheap. Okay, so I think that should be good. We're gonna try it over here maybe. Now we have to be gentle when cleaning. We do not want those wires to rip. So we're gonna be gentle. And we have a customer. And I'm the only one who has to go talk with the customers today. Be right there. Dolly is taking care of the calls and customer service, but nobody to talk with the customers today except me. So just a minute. What's wrong with it?
You can only charge if I hold it at a certain angle.
Okay, so let's continue working on this. Just be gentle, like wiping a baby's butt. Very gentle. I do not wipe my kids' butts myself, my wife does. And I always tell her I do not know how women can take the smell. I mean, I feel like throwing up when I do it. Women are just pre-built to handle these things. So all I need to do is just tin the wires. This is the non-enameled wire, so it's very easy to tin. I mean, something is keeping this port from going down, so this is the wrong port. This is not the right port. Yeah, this is definitely not the right port. Look at this. Look at the two tabs that you see down here, this and this. So this one will not work unless maybe we cut those tabs off. Let me check the second port the customer mailed over. And same thing. Same thing, it's not gonna work out. So we have to cut the tabs. Wow, wow. And honestly, this blade is a multi-purpose, multifunctional blade. I used it for the solder mask. I used it to scrape off the mask from the lines. I used it to cut those tabs off. You know, I like the fact that the blade is from the inside. It comes in handy to do a lot of things. Let's try it now. Perfect. Perfect. I mean, the port is not meant for this drive, but because we cut the tabs, now it's better than before. Okay, so one side is soldered, and let's do the other side so we can hold it down in place. Just a tiny bit of flux. Very nice. Look at how nice those jumper wires are. And finally, this one here. Okay, we should be all good. Let's test. This one is good. This one is good. 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 Very nice. This one should move with the wire. So we should be good. All we have to do is try it and see if it works. Considering nothing else is wrong with the drive, it should work and we should be able to get the files. So right here, it looks nice. I'm gonna plug it in and we'll see. I'm about to plug it. 1, 2, 3. The light came on. The light came on, but nothing appeared on the computer, and I can feel a lot of heat on that drive. I can feel a lot of heat on that drive. Burning heat. A lot of heat. Something is going on with this. Something is going on here. Something is going on here. Something is heating up a lot here. Almost seems like this capacitor may be shorted to ground. The light did come on, but something is getting extremely hot. Hot means we have a short. Is it possible that we have a short on this cap because heat was coming from this area here? Meter in diode mode, red probe on ground, and no short. We do not have a short here. So what's happening? I have to monitor this under a thermal camera to see where heat is coming from. And we have a short here. We have a short here. It could be a bad controller. If the short is coming from this controller, it's game over. We cannot get any files. If the short is coming from the capacitor, then we can remove the capacitor and get the files. Okay, so the short is coming from here. So we have a short here. Let me check the meter in ohms mode. I want to see, is it a dead short to ground? Meter in ohms mode, and let's test this capacitor here. And it's a 0 ohm. 0 ohm short. What about this one here? 0 ohms. And 1.2 ohms. That's a dead short. That's a dead short. I'm going to go ahead and remove this capacitor and see if we can release the short. And I'm going to also check this under a thermal cam to just confirm that heat is coming from this area. None of the capacitors are shorted to ground on this side of the board. Okay, so let's move it to right over here. If our short is gone, then the problem is this capacitor. The problem is not the capacitor, we still have a short. Okay, this is done. Let's check, do we still have a short? And yes, we have a short. What can you do? What can you do? So right now, we soldered the capacitor back. We soldered the capacitor back, and the short is not coming from the capacitors. We have a dead short here, 0 ohm short, and 0 ohm short here, and those components are pointing to the chip. The line is going to the chip. So most likely we have a bad controller chip. That's unfortunate, because right now the only way to get a replacement controller chip would be to have the same exact flash drive, same batch. Otherwise, we cannot get this controller. The other way to recover data from this flash drive would be to send it to a data recovery lab where they would do a chip of data recovery. But as far as the circuit board itself, we did what we had to do. And unfortunately, it's a no fix as of now. One last thing I want to do is check this board under a thermal cam just to confirm that heat is being generated by the controller chip and nothing else. Whoa, what is this? What is this? It just flared with heat. "303 degrees. Wow. Wow, that's a huge short. Based on my findings with the thermal camera, heat is coming from this chip here. And let's apply low melt solder. See? That's the beauty of low melt solder. Now I just have to let go of that chip. And let's see, do we still have a short? Let's check and see if we still have a short. Meter in diode mode, red probe on ground, and black probe right here. And we still have a short. Okay, so the problem is not this component. Even though a lot of heat was being generated by this component. What I want to do is remove the socket. Maybe the socket that the customer sent is wired differently from the inside and it's causing a short. Okay, I just removed it. I just removed the socket and I'm gonna test again to see if we still have a short. Now, if we do not have a short, then the problem is the socket. And I should not have used the socket the customer sent, especially that it had the tabs on the bottom. Maybe it's wired differently. The socket may be wired differently, but let's check to see if we still have a short after we removed the socket. Red probe on ground. And look at that. Wow. We no longer have a short. We no longer have a short. So the problem is the USB socket. Wow, wow, wow. All that work for nothing. The problem is the USB socket. Since we do not have a USB socket or the proper USB socket to solder on here, we're going to be using 4 wires from a USB 2.0 cable. But we have to figure out where 5 volts should go, where ground should go, where D minus should go, and where D plus should go. On a USB 3.0 layout, pin number 2 or pad number 2 and pad number 5 should be ground. So if I were to make an educational guess, I would say this is ground. And yes, 3, 4, 5.